With the transactions now recorded in the blockchain, the next step is to calculate the wallet balance based off of those historical transactions. The basic idea is that your balance at any time can be calculated by summing all the outputs you own. Essentially, check each transaction in the blockchain history. If the wallet public key matches the output recipient, then add that output amount to the blockchain balance. Now, beyond that, there's a little more nuance, which we're going to explore through test-driven development. I'd also like to mention that we're near the end of the blockchain backend now. These last few tests that we write will therefore be probably the most deep and complex ones yet, since they're going to involve a lot of aspects of the project. But these huge methods are really the heart of the system and what makes the project really powerful. And it's what we've been working so hard to be able to do. But to begin, let's describe a new calculate balance function within the wallet/index.test.js file. I'm going to collapse all these other functions, and then I'm going to add the describe calculate balance group of tests. So this is for a group of tests around a calculate balance function. Cool. For this test, one thing that we don't have that we do need is a blockchain instance. After all, the balance will be calculated based off of summing all the outputs dedicated to this wallet throughout the blockchain history. So let's make a local blockchain variable for the tests. I'm going to call this blockchain. And then within here, we'll have a before each function that sets this blockchain variable to a new blockchain instance for every single test. So the blockchain is going to be a new blockchain instance. But this does mean that we need the blockchain class at the top. So at the top of the file, let's make a constant of blockchain. And this is the result of requiring the blockchain/index.js file that is located one directory back in the blockchain directory. Cool. Now, if the balance is calculating by summing all the outputs to the wallet, then there's two cases to consider. The first case is that, well, there's no outputs for the wallet. Let's describe that. And there are no outputs for the wallet. All right, cool. And let's write a test case for this first. In this case, if there's no outputs for the wallet, well, the function should return the value of the starting balance. So we'll say it returns the starting balance. And to mark this as a hard-coded value that is global, we're going to use the backticks as usual. Nice. Now, how are we going to calculate this balance? Well, it's going to be a static function within the wallet class itself. So we'll call wallet.calculateBalance directly on the class. And this is going to have two fields coming in to an incoming object. First, it's going to have a chain, which is going to be a chain array from a blockchain instance. So we can use the blockchain.chain. And then second, it's going to have an address to calculate the balance for, which in this case is the wallet.public key. And then the return value of calculate balance is the balance of the entire wallet in consideration of all of its outputs, as well as the starting balance in consideration of the entire blockchain history. So let's expect that we have a value that returns the starting balance of the overall system. So we have that global starting balance value. And then that expected value should be equal to this actual value that we get from calculating the balance. So go ahead and plug in that code into the expect function. Now we do need to require the starting balance from the top of the file. So at the top, make sure to have a constant of starting balance. And then this is the result of requiring that value from the config file located one directory back. Nice. Once you have that, we can get to the other case. And in this case, we actually do have some outputs for the wallet. We'll describe, and there are outputs for the wallet. Cool. In the context of these tests, let's set up a few transactions. We're going to make two transactions, and we're going to set them both to variables, so that way we can track how they've been calculated and recorded in the blockchain, as well as their output values when we want to make expectations on the actual expected value. First, we're going to have a transaction 1 and then a transaction 2. And then before each test, let's actually set these transactions to actual transaction instances. So the first one is going to be transaction 1 is equal to a new wallet.create transaction call. So note that we do have access to the wallet class at the top of the file, which allows us to call the create transaction method. So that way all we have to pass is a recipient, which in this case is going to be the wallet public key, and then an amount of 50, which should be a valid amount. So we could have made a new transaction instance itself by using the transaction class, but again, this makes things a little neater since we don't have to pass in the sender wallet public key explicitly. Let's do something similar for transaction 2. So for transaction 2, it's pretty much going to be the same thing, except we're going to use another new wallet. We'll call create transaction again. The recipient is the wallet.public key. And the amount, let's make slightly different. How about 60 instead? Cool, so that takes care of our 2 transactions. Now we want to make sure these transactions are recorded in the blockchain history. So we're going to use the blockchain and add a block. This will consist of some data, and the data is going to be an array of both of these transactions. So we'll include transaction 1 and transaction 2 in this array. Nice. Now we can get to writing some tests. Now for our first test, it's going to say that it adds all of these outputs from the transactions to the wallet balance. After all, the wallet is the recipient in both of these cases. So let's say it adds the sum of all outputs to the wallet balance. And I'm going to make sure outputs is spelled correctly. All right, cool. Then we have the callback function here. Nice. In this case, we're going to calculate the sum once more. So we're going to do wallet.calculateBalance once more. The chain is the local blockchain.chain, and then the address is the wallet.public key. Cool. And let's expect this to equal a certain value. So we're going to have our expect function, and then this is the actual value. And then this should be equal to a calculation of the starting balance plus whatever outputs they've received from both transactions. So they're going to have one transaction from transaction 1. So we're going to add transaction 1 dot output map, and then we're going to access the amount that is held by the wallet.public key. And we're going to do the same thing for the second transaction. So transaction 2 also has an amount specified for the wallet.public key within its output map. So that should be the overall balance of the wallet public key if you look at the history, because it received these 2 transactions. So those outputs in addition to the starting balance. All right, cool. Now just to review the code, and one thing that I'm noticing is that this it block is outside of the proper scope. This should be after the before each, so be sure to address that if you made the same small issue. But yes, we're going to check that it adds a sum of all outputs to the wallet balance, and in addition, calculate balance should return the starting balance if there are no outputs for the wallet. All right, now let's go ahead and run the test. So open up the command line and fire npm run test. And as you do so, the very first thing that isn't going to be available is that wallet.calculateBalance is not a function. All right, cool. So now in the index.js file, let's make sure to have this method. We're going to have a static calculate balance method. And then this is going to take in an object that consists of a chain and an address. And our strategy with this is to first up, let's return the starting balance, since that is the default behavior for calculate balance. And as we do this, we should see that one of the tests has passed, and we now have only one remaining test to make sure that the outputs for the wallet are added to the sum. So that initial test of the starting balance is now passing. But the idea now is that we want to add any outputs for this address that have been recorded in this chain to this return value. To track that, let's start out with an overall outputs total, and we'll set that to 0. And then we're going to go through every transaction in the chain, and if the address has an output within the transaction output map, we'll add that to the outputs total. Let's skip the Genesis block since it doesn't have any transaction data. So first for let I equal 1, and then I should be less than the chain.length. And then we're going to increment I, so with I++. Great. Now we can set I, or rather use I to access the current block, so make a constant of block, such a chain of I. And then using a for let of block, we can look at every transaction by using the block.data. All right, nice. And this allows us to make a constant of address output that is the result of attempting to access the value in the output map at this address. And the great thing about this is that even though the address output won't always be defined, well, we only care about the cases where there is a value. So if we have a check on the address output map, or rather the address output itself being defined, then we can have some code that adds this address output to the outputs total in all the cases where there is an actual value. In other words, in the cases where the wallet has received a transaction. So we're going to say outputs total equals outputs total plus the defined address output. All right, nice. And the final thing that we need to do is make sure that this outputs total that has been calculated is now added in addition to the starting balance. Cool. So overall, the starting balance will remain the actual value if there are no outputs for the wallet. Otherwise, we're going to add all of those outputs to the starting balance. So on a save of this, you should find, if all goes well, that the test suite becomes fully green, fingers crossed, and indeed it does. All right, cool. So now we have a calculate balance function that is doing at least the starting balance check and then the outputs total check. Now we still need to add additional logic as you reviewed to make sure that we only add outputs after the most recent transaction for the wallet. But first up, as our next step before we do that, let's make sure that the wallet balance is now accurate by checking this method every time the create transaction method is used, which bases the transaction based off the current wallet.balance. Okay, let's do that next.